Okay, so picture this. You walk into your kitchen, you're craving a snack, right? But not just any snack. You want those rice chips, the ones buried in the back of that bottom drawer, the one the robot never seems to remember.
Sounds like a recipe for disaster, or at least a lot of crumbs.
Right. Well, today we're diving into some seriously cool AI research that could actually make this whole robot helper that actually helps thing a reality.
And no, we're not talking about some far-off science fiction. This is happening right now. We're talking about PaLM, an AI that's not just smart, it's got this incredible ability to understand what it sees just as well as it understands what you tell it.
Okay, so hold on. No more pre-programmed robots with their limited to-do lists. We're talking robots that can actually learn as they go.
You got it. That's the beauty of PaLM-E.
Uh,
It's breaking down those walls between language and vision. Imagine trying to understand a concept by just flipping through a dictionary, right?
hmm.
Versus having an actual conversation with someone. PaLM-E is like that aha moment for robots, where they start to connect the dots between the words and the images, the meaning behind it all.
Okay, I'm intrigued. The paper mentions that PaLM-E can process both text and images simultaneously. So it's not just seeing a chair, it's understanding what a chair is, how we use it, what it's for.
Exactly. And it's not limited to just one image at a time. It can process a whole series of images. Think about it like watching a movie instead of just looking at a single photograph.
So it's getting the whole story, the context.
Precisely. It starts to understand the concept of sequences. You setting the table, maybe the dog sneaking in for a drop crumb, real life stuff.
That's wild. Okay, so back to my rice chip dilemma. If I were to show this AI a bunch of videos of me getting snacks from different drawers, could it start to predict, I don't know, maybe where I'm headed next time I open the pantry?
That's the idea. It's like
Mm.
PaLM-E is building this mental map of its surroundings. It's not just seeing a bunch of objects. It's understanding how they relate to each other, how they're used, their purpose.
So it's not just move object A to position B. It's, hey, robot, I totally burned dinner. Any chance you could give me a hand?
Now you're getting it. This paper goes deep into how PaLM-E tackles those real-world challenges, even the ones that involve, understanding what we mean, not just what we say, which
Well,
is trickier than it sounds.
for sure. So how does it actually work? The paper mentions these state estimation vectors, and, well, I'll be honest, that sounds a little intimidating.
I get it. It sounds very technical, but think of it this way. You probably have a mental map of where things are in your kitchen, right?
I'd like to think so, yeah.
State estimation vectors, they're basically like an internal map for a robot. It helps them track where things are and what those objects are like.
So my robot wouldn't just see a jumble of random stuff. It would remember, okay, she always keeps the rice chips in the bottom drawer, even if I left it slightly ajar in a moment of forgetfulness.
Exactly. It's all about context and memory. And it gets even cooler. PaLM-E uses these things called vision transformer.
Vision transformer.
Yeah, or VITs for short. They're like the art critics of the AI world.
Okay. Tell me more.
They break down images into all these little parts and figure out what's important. Like the difference between a chair leg and, say, the pattern on the rug. It's all about understanding how the pieces fit together.
So instead of just seeing a jumble of pixels, it's actually recognizing, okay, that's a chair, that's a table, and is that the dog eyeing the counter again?
You got it. But they didn't stop there. They took it a step further with this really cool thing called the Object Scene Representation Transformer.
Try saying that 3 times fast.
I know, right? OSRT for short. And basically, it's like giving the AI 3D vision just like we have.
So instead of seeing a flat image, it understands how objects actually exist in space. That's a game changer, right?
Yeah.
But did they actually test this on real robots, or is this all still theoretical?
Oh, they absolutely went there. They tested PaLM-E in 3 different settings, starting with this thing called task and motion planning, which is a mouthful, so we'll just call it TAMPEAK. Think of it like giving a robot the extremely complex task of picking up a block.
Hold on a sec. Picking up a block is complex. My niece, she's 2, she's got that one down.
Well, yeah, for us it seems simple, right? But for robots, even those little actions, they involve a ton of calculations. They need to understand, like, physics, how much force to use, how objects move, all that. That's where PaLM-E's planning abilities really come in.
So it's not just seeing the block, it's figuring out all the steps to actually grasp it, without turning the whole place upside down in the process.
Precisely. And get this, the paper highlights how PaLM-E, it managed to do all this with way less real-world training data than you'd expect.
Wait, hold up. Less training data? Just how much less are we talking here? Did they just, flash a picture of a block at this thing and say, all right, go get it?
Not quite that extreme, but it's pretty impressive. For some tasks, PaLM-E was effective with just 1% of the typical training data.
1%? That's like acing a test after, like, glancing at the first page of the textbook. How is that even possible?
That's the magic of transfer learning right there. See, all that knowledge that PaLM-E soaked up from just like gobbling up language and images from all over the web, it's like it took all that and applied it to these robotics tasks.
So it's not starting from scratch. It's bringing all its experience to the table, no pun intended. Speaking of tables, you mentioned they tested this in a, what was it, a language table setting. What kinds of challenges did they throw at it in that environment?
Okay, so picture this. A table covered in a bunch of random things, right? The task was pretty basic. Get the robot to sort it all out by color. Sounds simple enough, but then to make things interesting, the researchers, they went ahead and pushed one of the objects while the robot was working.
Oh, talk about a curveball. Did it totally freak out?
Nope. PaLM-E was able to adapt and just like keep on sorting, even with that surprise changeup. It shows a real knack for real-time problem solving that you don't see every day in a robot.
Color me impressed. So, from these carefully arranged tables, they then decided to take this show on the road, straight into a real-life kitchen. That seems kind of brave.
Brave, sure. And you know what? Surprisingly successful. This is where things got really interesting. They gave PaLM-E control of a robot in an actual kitchen.
Oh, wow. Okay.
Yeah. And they'd tell it to do things like, hey, can you grab me something to clean up this spill? You know, real world stuff.
Now that's something I can get behind. A robot that cleans up my messes. Sign me up. So did it actually work?
It did. The paper describes how PaLM-E, it was able to break that instruction down into all these smaller steps, like find a sponge, go to the sponge, pick it up, bring it back, all without someone telling it each tiny little detail along the way.
Hold on. Without explicit programming, it just figured all that out on its own?
That's the thing. It's not about rigid commands anymore. It's about understanding what we mean the intention.
Yeah.
It used its knowledge of, like, language, objects, maybe even a little common sense to actually come up with a solution.
Okay, that's some next level stuff. I'm not gonna lie, I'm kind of blown away. And the paper also mentioned this other cool thing, something about PaLM-E being able to understand affordances. Is that like robot speak for thank you?
Not quite. But it is about robots understanding how our world works. Affordances, they're all about what an object allows you to do with it.
Okay, so a chair affords sitting. A door handle affords pulling. Gotcha. And PaLM-E gets that.
Exactly. It's not just identifying an object, it's figuring out what that object is for, even if it's, like, never actually seen that particular object before.
So you're telling me if it encountered like a brand new type of chair, it could still figure out that its main purpose was probably sitting.
That's the idea. Now, they didn't test every single object under the sun, of course, but the research seems to suggest that PaLM-E can actually generalize its knowledge like that. And that is a huge, huge step toward robots that can function in a more independent way, out in our messy and predictable world.
It's pretty incredible. But I gotta ask, on this talk about picking up blocks and fetching sponges, it makes me think PaLM-E is like destined for a life of chores.
Oh, it can do so much more than just tidy up. Those examples, just the tip of the iceberg. PaLM-E's real potential goes way beyond that. We're talking like healthcare, education, even creative fields. This tech could seriously change how we live and work.
Okay, now we're getting to the good stuff. Give me the big picture. What kind of impact could PaLM-E actually have on our future?
All right, so I'm definitely sold on the idea of PaLM-E taking over my to-do list. Robot that can sort laundry, sign me up. But let's talk big picture now. How does this tech actually shake things up in fields like, healthcare or education? Those feel huge.
Oh, absolutely. Think about your surgeon, right? You've got this AI assistant by your side. But we're not talking just passing instruments back and forth. This assistant can actually anticipate your needs, what you'll need next, just based on what's happening during the surgery.
Whoa, okay, that's some next level stuff. It's like a mind-reading surgical assistant, which I have to say is both amazing and a little bit freaky, right? Intense, for sure, but the possibilities are incredible.
Yeah.
Or picture this robots with PaLM-E's abilities, but they're assisting elderly individuals, not just with, like, the physical tasks, but they can actually understand those unspoken needs we were talking about.
Oh, that's huge. So not just bringing a glass of water, but maybe sensing if someone seems disoriented and actually, like, calling for help. That level of understanding, that's a game changer for independent living, right?
Exactly. It's that ability to adapt that really makes a difference. I mean, with some training, PaLM could be applied to so many healthcare situations,
Yeah.
from hospitals to, like you said, even people's homes. It could make a real difference in people's lives.
Okay, you have officially blown my mind. And we
Yeah.
haven't even touched on education yet. You mentioned those personalized robot tutors earlier.
Right. Imagine a tutor that actually gets how you learn best, offering explanations that make sense to you, maybe even using objects to actually demonstrate a concept. It's like having a hands-on teacher that can show you, not just tell you, how things work.
Okay, now that is cool. I mean, it could be incredible for those subjects like math or engineering where actually being able to visualize a concept is so important. This could really open doors for students.
Absolutely. It's all about using technology to help us unlock our potential, right? That's a really exciting thought.
It is, but this ability to actually understand the world around us, to plan, to, like you said, anticipate needs, it feels like a lot of responsibility for a machine. Does this research even touch on those bigger what-if questions?
It's a great question, and you're right. It's something we definitely need to consider. As we weave these incredibly capable robots into our lives, we have to be mindful of the implications.
Right.
It's a constant conversation, but that's how progress happens.
100%. This research, it's not just about some cool new algorithm, it's about actively shaping our future with these advancements. So, where do we go from here? What's the big takeaway you want to leave our listeners with today?
Well, the researchers behind PaLM, they envision a future with what they call general-purpose robots. Machines that can learn, that can adapt, and most importantly, collaborate with us in ways, honestly, we're just starting to imagine. It's up to all of us to decide what that future looks like.
A future where robots are more than just tools, they're partners. I'm into it. Thanks for diving into all of this with me today.
Anytime. Until next time.